Hello guys, and welcome once more to this new video on our YouTube channel. So in today's video we are going to be solving a very interesting question on pure mathematics with mechanics. So this particular video we are going to be solving the Littoral mock 2025 pure mathematics with mechanics paper 3. So we are going to be solving question 1 of this mock. The question reads: the speed of a particle p which starts from rest at time t is given by bt equals 18t minus 3t squared when t is greater than or equals to 0, less than or equals to 4, and this same bt is actually equals to 32 minus 2t when t is strictly greater than 4 seconds. In the Romans one, we are asked to find the maximum speed of p within the first 4 seconds of the motion. In the Romans, we are asked to show that p covers the distance of 80 meters in the first 4 seconds of its motion. In the Romans, we are asked to determine the time at which p momentarily comes to rest for t strictly greater than 4 seconds. And in the Romans, we are asked to find the time p takes to cover the first 208 meters. We can actually learn into the solution of this question. So the A part of the question asks us to find the maximum speed of p within the first 4 seconds of the motion. But we know that what from the question given to us, we know that for the time interval, that is for the first, when we are talking about the first 4 seconds of the motion, it simply implies that the speed of the particle in this time interval corresponds to 18t minus 3t squared given from the question. That is, for t greater than or equals to 0, less than or equals to 4 seconds, we have the speed which actually corresponds to 18t minus 3t squared. But we know that what? We know that at maximum speed, the acceleration is actually equals to 0. And with this condition, we are simply going to obtain the value of t which corresponds actually to this acceleration being equals to 0. And from that value of t which we are going to obtain, we are simply going to come and determine the maximum speed by simply doing what? Substituting the value of t which we are going to obtain using the condition of the acceleration being equals to 0 to get the maximum speed actually. So at maximum speed, the acceleration is equals to 0. And we know that acceleration actually corresponds to what? The acceleration is what? If we want to get the acceleration, we simply need to differentiate the speed. We simply need to differentiate the speed with respect to time. And differentiating the speed with respect to time, that's differentiating this expression, that is 18t minus 3t squared, with respect to t, we are going to have 18 minus 60, and from which we can therefore come forward and get the value of t, which is actually 3 seconds. And we can therefore say that the maximum speed occurs when t equals 3 seconds. Why? Because at maximum speed, the acceleration equals to 0. And from this condition, we obtain that value of t, which corresponds to the time at which we have maximum speed. That is, at maximum speed, we have t equals 3 seconds. And having this value, we can therefore come forward and substitute that value of t inside the expression of the speed. Okay, because we know that at this time, maximum speed occurs. We can therefore come and substitute it, and we get the maximum speed, okay, to be equal to 18 then times 3 minus 3 then times 3 squared, which gives us 27 meters per second as the maximum speed of p within the first 4 seconds of the motion. Which answers the A part of the question actually. So in the Romans 2, we are asked to show that p covers the distance of 80 meters in the first 4 seconds. Obviously, since we are still on the first 4 seconds, that is, for t greater than or equals to 0, less than or equals to 4, the speed is actually equals to what? 18t minus 3t squared. So it is with this speed that we are going to proceed with the solving in the Romans 2. Very important. Take note of it. So this was the trick in this particular question. The trick was simply for you to identify which speed corresponds to which time interval. Depending on the question being asked, identify the time interval, and from that time interval which you identify, you come forward and use the speed which corresponds to that time interval to answer any question on that particular condition. Okay, yes. So this was a small trick on this particular question actually. So we know that what? We want to show that p covers the distance of 8 meters in the first 4 seconds of its motion. But we know that what? For the first 4 seconds of the motion, the speed actually corresponds to what? The speed is actually equals to 18t minus 3t squared. Now, we know that what? We want to show that p covers the distance of 80 meters in the first 4 seconds. Now, what are we looking for? It simply means this 80 meters will actually correspond to the distance. Okay, we are simply going to do what? We are simply going to use the speed which we obtain. That we are simply going to integrate the speed which we obtain to actually get the distance. Because we know that what? If we integrate the speed, we actually get the distance. So integrating the speed with respect to time, we simply get the distance. And that is what is being asked for us to determine in the question. Obviously, including the boundaries of the interval, which actually from 0 to 4. Why? Because it is in this time interval that we have the speed being equal to 18t minus 3t squared. So the distance is actually going to be equal to what? The integral of the speed with respect to time from 0 to 1, which corresponds to the time interval corresponding to the speed 18t minus 3t squared. And integrating it with respect to time, we get what? We get 9t squared, then minus t cubed, the power of integration from 0 to 4. Obviously, why? Because if you integrate 18t, you are going to have 18t squared divided by 2, but 18t squared divided by 2 gives us 9t squared. And if you integrate 3t squared, you are going to have 3t cubed divided by 3, which gives us t cubed. And the bounds of integration from 0 to 4. When we further simplifying, we are going to get, putting the bounds of integration, we are going to get the speed, we are going to get the distance of the particle to be equal to what? To be equal to 80 meters, which is actually what we require for us to prove that if you do this equation, that is 9 times 4 squared, then minus 4 cubed, we get this distance of 80 meters to correspond to the distance covered by P, by the particle P, in the first 4 seconds of its motion. Which was actually what was being required for us to answer in the Romans 2 of the equation. The Romans 2 of the equation, we are asked to determine the time at which P momentarily comes to rest for t greater than 4 seconds. Obviously, for t greater than 4 seconds, what speed corresponds to that time interval is actually the speed 32 minus 2t. So in the equation, in the Roman 3, all the solving we are going to do, we must take into consideration that the speed corresponding to this condition, that is for t greater than 4 seconds, the speed is actually equals to 32 minus 2t. Very important, actually. But now in the equation, we want to determine the time at which P momentarily comes to rest. We know that what? When P comes to momentarily rest, the speed is actually equals to 0. So we are simply going to equate this speed to 0, and equating it to 0, we are simply going to get the time at which P momentarily comes to rest in that time interval, actually. So we know that what? The speed actually equals to 32 minus 2t, equating it to 0 from the condition of the fact that P momentarily comes to rest. We have therefore 32 minus 2t to be equal to 0, from which we get t. That is the time at which P momentarily comes to rest for t greater than 4 seconds to be 16 seconds. Now in the Romans 4, we are asked to find the time P takes to cover the first 208 meters. Now, we know that what? Since P covers a distance of 80 meters in the first 4 seconds, what are we going to do? We are simply therefore going to use this first condition, because this first condition is going to help us a lot in the next part of the question. Why? Because if particle P covers 80 meters in the first 4 seconds, and we know that what? We want the time P takes to cover the first 108 meters, what are we going to do? We are simply going to do this 108 meters minus 80, and doing that we are going to get 128 meters. And with this distance, that is with this distance 128 meters, we are simply going to do what? We are simply going to determine the time, the time at which the particle P takes to cover this 128 meters, simply. Very important. That is, we know that what? The distance, that the remaining distance, which is actually 128 meters, what are we going to do? We are simply going to use the condition of the fact that the distance is actually the integral of the speed. But now take note of it. Since the particle first of all covers the distance of 80 meters, in the first 4 seconds, it means as from the 4th second to the time x, which we don't know and which we are looking for, is going to correspond to a distance of 128 meters covered by particle P. Very important. So this 128 meters being left, is going to do what? This 128 meters, the particle P is going to cover it as from the time interval 4 seconds to a time x, which we don't know. That a time x which we are going to be looking for here. So this is what we have to do in this particular question. Take note of it. That is, for the 128 meters corresponding to the distance covered by the particle P, the time which particle P is going to take to cover this distance is going to be from 4 seconds to an x time which we don't know and which we are looking for. Very, very important, because we know that for the first 4 seconds, particle P covered a distance of 80 meters. Then for the remaining 108 meters, what time will particle P cover? And that's what we are trying to figure out here. Very important. That is, doing that, we are simply going to integrate this speed in this time interval, because this time interval corresponds to the time interval t greater than 4. So using the speed, which actually 32 minus 2t, We are therefore going to have what? 128 to be equal to the integral of that speed with respect to time from 4 to x. And if you do that, if you integrate that, if you integrate 32 minus 2t, we are going to get 32t then minus t squared, including the bounds of integration, that is from 4 to x. And if further simplifying, we are going to get what? That is, if you put the upper bound, that is, if you put upper bound minus lower bound into this expression of the integral which we have determined, we are going to get 32x minus x squared then minus 128 plus 16. That if you put x first, that is 32x then minus x squared then minus, if you put 4, that is, you are going to have 32 times 4, will give us 138, then minus 16 will give us actually plus 16 actually, for which further simplifying we are going to get 128 to be equal to 32x then minus x squared minus 112, which implies that we are going to get a quadratic equation, that is x squared minus 32x plus 240 to be equal to 0, from which solving it, that we are going to solve it using the formula method, that is to get the first, that is we are going to solve it and get the factors, that is solve the quadratic equation, and solving that using the formula method, we are going to get x1 to be equal to negative b, but b is negative 32, negative b actually 32 plus square root of what? B squared minus 4ac, b here is actually negative 32, and then minus 4a, a is 1, then c is 240 divided by 2a, a is 1, and we do same thing to get x2, x2 is actually what? B squared negative b minus, because in this case I use for x1 I use plus, then for x2 I simply use minus, from which further simplifying we get x1 to be equal to what? 20 and x2 to be equal to 12. Okay, that is further simplified because this expression is going to give us 64. Square root of 64 gives us 8. We're going to do 8 plus 32, which gives us what? 40. Then 40 divided by 2 gives us 20. And similarly here, square root of 64 gives us 8. Then 32 minus 8. 32 minus 8 divided by 2 gives us actually 12. Now take note, this exercise said is the x is going to correspond to the time p covers. Is going to correspond to the time p takes to cover the first 208 meters. Why? Because this time x corresponds to the last time value, okay, which particle p covers after covering a distance of 208 meters. Okay, yes. Now what are we going to realize in this particular question? Take note, since p momentarily comes to rest, that is, since p comes to momentary rest at t equals 16 seconds, from these two times we are going to eliminate one. Why? Because we know that what? This x, this 20 cannot be there. Why? Because we know that what? Particle p comes to momentary rest when t equals 16 seconds. So all the values of time above this 16 seconds is not going to count. It's not going to enter in our question. So the only time, the best time which corresponds to this is going to correspond is actually going to be equal to 12 seconds. Why? Because this 12 seconds is not above 16. It is actually less than 16, but doesn't reach 16. But it could have been 16. But if we have been the case, we are then taking 16. But this 12 corresponds to that time because this 12 is actually less than 16. But this 20 cannot be taken. Why? Because this 20 is not valid. Why? Because we know that particle p comes to momentary rest when t equals 16 seconds from the Roman 3 which we obtained. That is, since p comes to momentary rest at t equals 16 seconds, we can therefore conclude that the x which we are going to consider is going to be 12 seconds. Why? Because x can't exceed 16 seconds as I was explaining actually. So we can therefore conclude that the time p takes to cover the first 208 meters is actually going to be equal to 12 seconds. Remember, I started from 4 here to the distance x, to the time x, that is 4 seconds, to the last time, that is to the time which p is going to cover the entire 208 meters, which actually corresponds to 12 seconds here, from which we answered the Romans 4 of the question. So this was a very interesting question, and I invite the student to pay kind attention. If things are not clear, you can get to me inbox. I will try to explain much into it, that I will try to enter deep into it if the concept was not clear. But this particular question was a very interesting one, so I will invite students to have a nice look on this particular question. So thank you very much for watching this video, and don't forget to like, subscribe, share the content with your friends for them to benefit from the good explanation as well. So thank you very much for watching this video, and see you then for the next interesting video. Bye bye.